Welcome, Focus Learners, to this explainer. I am absolutely thrilled to have you here today because we are going to fundamentally transform how you tackle your Cambridge IGCSE and O-level computer science questions. Think of your exam strategy like being a cricket captain. To win the match, you literally can't just walk onto the pitch and start swinging your bat wildly at every single ball. You need to set your field. You need to read the bowler, who in this case is the Cambridge examiner. And then, with absolute precision, you score your runs. And your runs, of course, are your marks. Whether you are sitting for syllabus codes 0417, 0478, 2210, or 9618, the strategy we are unpacking today is your ultimate playbook. Let's start by looking at a real challenge. Imagine a typical Cambridge past paper question, let's say from a recent 0417 paper. We have two very common types of students sitting in that exam hall. First, we have Alex. Now, Alex is absolutely brilliant at memorizing. But in an exam setting, Alex overloads the answer sheet with raw computer science facts. It's just a massive, unstructured data dump with zero analysis. Alex sees the word binary and just writes down every single thing they know about base 2. The result? The examiner's red pen is everywhere. Then we have Sam. Sam definitely knows the material, maybe even better than Alex, but Sam rushes. Sam completely misses the command word requirements. Sam describes what a concept is when the question specifically asks to explain how it works. And again, more red pen marks. It's frustrating, right? You put in the hours, you know the content, but the marks just aren't there. Well, today, we are going to fix both of these flawed approaches. We are moving away from rote memorization and stepping up to true examiner-level mastery. Okay, let's dive into this. Here is our structured roadmap for today's session. We'll start by defining the digital problem, then move into the 3 layers of explanation, break down the method mark strategy, highlight some absolutely crucial examiner warnings, and finally wrap up with the 4-question check. Let's get right to it. Section 1. The digital problem. Let's identify the exact concept we're dealing with. Far too often, students treat computer science like it's just a giant vocabulary list. You know what I mean? You memorize that binary is base 2, you memorize that Denary is base 10, you learn the mathematical conversion methods, and then you just stop there. That is exactly what Alex does, and that is precisely why Alex loses all the higher-order evaluation marks. If you view these number systems as isolated definitions, you are entirely missing the architecture of the Cambridge syllabus. A strong foundational understanding begins with identifying a digital problem. We need to identify the exact concept involved and then link that concept directly to the style of explanation that appears in your past papers. To do this, we use something called the PEEL framework. That stands for point, evidence, explanation, link. Keep that framework in your mind because it's going to be your best friend. So I want to ask you this directly, and I want you to really think about it. What digital problem does binary actually solve? Before we introduce bits or bytes or logic gates or MAC addresses, why did engineers literally invent binary in the first place? The problem is that a computer is essentially a massive collection of microscopic electronic switches. It doesn't understand the letter A, it doesn't understand the number 5, and it certainly doesn't understand a high-definition video file. It only understands one thing: voltage. It understands power on and power off, true or false, 1 or 0. Binary solves the fundamental digital problem of how to represent infinitely complex human information using incredibly simple physical electronic hardware. When you shift your mindset to this purpose-first thinking, you instantly elevate your ability to answer the high-mark evaluation questions. Why? Because you are thinking like an engineer, not just a student repeating a textbook. Before we continue to see how this applies to the real world, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now let's connect that to the real world. This brilliantly illustrates where that foundational knowledge actually goes. We are talking about phones, websites, databases, robotics, and banking systems. When you understand the practical consequences for a user or a massive system, the concept sticks in your brain. It converts pure memory into actual usefulness. Let's say a banking system processes millions of transactions. It relies on the flawless transmission of binary data. If an examiner asks you to justify the use of hexadecimal over binary in an error-reporting database, you aren't just reciting facts anymore. You understand that humans interacting with that database need denary or hexadecimal to process the information efficiently, while the machine underneath still desperately needs binary. Real-world context, my friends, is your golden ticket to full marks. Let's move on to Section 2, the 3 layers of explanation. This is all about moving from a simple idea to a highly technical, exam-ready answer. Now, what's really interesting about this concept is that it shows exactly where students get stuck. You see, students often think they know a topic inside out. They can recite the definition of binary in their sleep. But when they are sitting in the exam hall, under the immense pressure of that ticking clock, forced to express that knowledge in a specific format, they freeze. Or worse, like our student Sam, they rush and write the completely wrong type of answer altogether. You need to understand that the examiner is testing how you communicate your knowledge just as much as they are testing the knowledge itself. Cambridge assessment objectives are incredibly strict. Layer 1 is everyday language. You understand the simple concept. Layer 2 is technical vocabulary. You know the correct subject terms like registers, overflow, or character sets. And here's the trap. Most students, especially Alex, stop at Layer 2. They drop the technical terms and think they are done. But Layer 3 is the exam explanation. This is where you actually score the marks under pressure. Remember the Peel framework we talked about? Point, evidence, explanation, link. Your point is your direct, punchy answer. Your evidence is the technical fact backing it up. Your explanation is how the mechanism works, and your link connects it back to the real-world context of the question. If you are only operating at Layer 2, you are quite literally leaving up to 40% of your marks on the table.
This brings us to a massive transformation moment. The crucial difference between a description and an explanation. A description tells the examiner what something is. It's safe, sure, but it is incredibly shallow. An explanation tells the examiner how it works and why it matters. This is where the high-scoring marks live. Let's do a live rewrite for Alex and Sam. I'm going to give you a 60-second mental timer right now. Think about how you would answer this. Explain how a computer represents an image. As the timer ticks down in your head, think about Alex. Alex would just write, "It uses binary." That is a description. It's true, but it's a one-mark answer. Sam might write, "Binary is used so the computer can process the image data." Still too shallow. Now, let's rewrite this using our Peel framework for maximum marks. Point, the image is divided into a grid of pixels. Evidence, each pixel is assigned a specific binary value representing its color. Explanation, the number of bits assigned per pixel determines the color depth, meaning a higher number of bits allows for more colors to be represented. Link, this increased color depth ultimately increases the file size of the digital photograph. Do you see the difference? The red pen marks just transformed into green check marks. That is a masterclass explanation. But be warned, if you skip straight to the explanation without clearly naming the concept first, your answer will just confuse the examiner. You have to build it step by step.
Section 3, the method mark strategy. This is your disciplined path to replacing randomly ordered facts with a clear, logical answer structure. But real quick, stop scrolling, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's get back into the tactical application. This is the exact sequence of thought you need when you are sitting at that desk. This is the computer science success blueprint. Think of it like a progress bar for your mark potential. Right now, without a strategy, your potential might be hovering around 50%. By applying this blueprint, we are going to push that progress bar all the way to 100%. Here is your disciplined 4-step path. Step 1. Identify demand. What exactly is the command word? Is it state, describe, explain, or evaluate? Step 2. Classify concept. Are we talking about data transmission, hardware logic, or data storage? Step 3. Explain sequence. This is absolutely crucial. This is where process-based logic comes in. Step A happens, which triggers Step B, which results in Step C. Step 4. Connect to context. Bring your entire answer back to the scenario given in the question. Let's do another quick mental rewrite. Imagine a question about a factory sensor. Instead of doing a data dump about binary conversion, you identify the demand, say it's explain. You classify the concept, analog to digital conversion. You explain the sequence. The sensor reads analog data, the ADC converts it to binary, and the microprocessor evaluates that against a preset Denary value. Finally, you connect it to context, the factory temperature controlling the cooling system. Boom, perfect score.
And that connects beautifully to our next concept, real-world transfer. This is the act of applying technical concepts to a specific scenario, like a school, an office, or a banking system, rather than just leaving them in abstraction. If the exam question is set in a retail environment analyzing barcodes, your answer absolutely must speak the language of that retail environment. You talk about the laser scanning the black and white bars, converting light reflection into binary ones and zeros, looking up that specific binary code in the database, and retrieving the Denary price for the customer's receipt. Generic responses that just float in abstraction rarely gain full marks. The examiner wants to see that you can take the abstract theory of zeros and ones and apply it to a cashier scanning a carton of milk in the real world.
Section 4. Principal Examiner Warnings.
Let's shift to the pitfalls and highlight exactly where avoidable losses of marks happen. Examiners read literally thousands of papers, and they see the exact same mistakes year after year. Let's make sure you aren't one of them. We're going to run a quick interactive workshop right now. Challenge 1 is a data scan. I'm putting a 60-second timer on the clock in your mind. Look at the trends of common mistakes here. Examiners deduct marks when surface features or familiar words distract you from the deeper process. The common mistakes are vague wording, generic facts, and jumping sequence. Challenge 2, find the flaw. I'm going to give you a flawed sample paragraph, and I want you to spot the sentence losing marks. Here it is. The automated door uses a sensor. Binary is sent to the CPU. The door opens because it's hot. Did you catch it? The flaw is that last sentence. It completely jumps the sequence and relies on incredibly vague wording. The examiner commentary on this would be brutal. It would say, candidate failed to explain the analog to digital conversion and the logical comparison to a stored preset value. You fix this by using accurate paraphrasing and strict process-based logic.
Here is a phenomenal rule of thumb to live by to avoid those mistakes. Explain the mechanism first, then state the consequence. This adds total clarity to your sequence. Let's move into Challenge 3, speed writing. I'm starting a 30-second timer right now. Think about how to construct one perfect peel paragraph for why a web address is sometimes shown in hexadecimal instead of binary. Go. As the clock ticks down, remember, mechanism first. The mechanism is that hexadecimal condenses 4 binary bits into one single hex character. Okay, what's the consequence? The consequence is that this makes it significantly easier for human programmers to read, write, and debug without making transcription errors. Time's up. If you jumped forwards and backwards, if you started by saying, it's easier to read because it's shorter and uses 16 characters instead of 2, you totally break the logical flow. Mechanism first, consequence second. Every single time.
Let's move to Section 5 and see how this all builds into our final system, the 4-question check.
So, you have your exam strategy, you know how to read the command words, you understand the Peel framework, and you know how to avoid the examiner traps. But how do you actually study this at home so it permanently sticks? You don't just read the textbook and highlight paragraphs. Passive reading gives you the illusion of competence. We need active, error-aware retrieval practice. Whenever you finish revising a topic like binary or denary, you must ask yourself these 4 prompts aloud. Number 1, what is it? Define the concept clearly. Number 2, how does it work? Explain the mechanism and the specific sequence of steps. Number 3, where is it used? Give a real-world context, like a MAC address. Number 4, why is it better or worse than the alternative? Evaluate it. Why not just use Denary for everything? If you can't answer these 4 questions aloud, fluidly, without looking at your notes, you are simply not ready for the exam. You need another cycle of revision.
And that leaves us to the third pass revision. The first pass is learning the definitions. The second pass is practicing past papers, but the third pass, that is where the elite students live. In the third pass, you actively change the context. You mix nearby terms. You forced yourself to justify your choice. If you practiced a binary question about a factory, rewrite your answer for a hospital life support machine. You see, it all comes down to 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, a time management matrix that stops you from rushing like Sam. Error-aware notes and rehearsing answers under different scenarios are what truly prepare you. You are building mental resilience. I want to leave you with this provocative thought. Are your computer science answers floating in abstraction, or are they firmly anchored in the real world? The next time you sit down with a past paper, I want you to be the cricket captain. Read the examiner, set your strategy, and score those marks. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.